Hi, welcome to Parametric House, and in this Grasshopper tutorial we want to take a look at this Multipipe new component from Rhino 7, which you can find in the Grasshopper menu, Surface, and Sub-D sub-menu. Here you can see that we have this Multipipe, and we're going to take a look at this great component which has been added to Rhino 7. And we're also going to use this Maelstrom component to make these curves a little bit twisted, and then we're going to use the Multipipe component. We're also going to take a look at the gradient component in Grasshopper Rhino 7, so be sure to watch the video till the end. And finally we will have this in Rhino, how to extract the windows, and finish this tutorial. But before we start this tutorial, if you're new to our channel, welcome. Consider subscribing, and you can check out this playlist up here, which is for the beginners if you want to learn Grasshopper and why you should learn it. And if you want to learn Grasshopper step by step and from the beginning, you can enroll in our paracourse.com Grasshopper course. Okay, let's get started from scratch. First, what I want to do is to produce a series of curves. The reason I'm doing this is because the Multipipe component needs a series of curves or lines to make this subdivided surface in Grasshopper. Basically, a subdivision is a new component in Rhino Grasshopper. You can see that when I go to the Params menu and open up this geometry, we will have this sub-D component. You can also find it here in the surface and sub-D menu. And in Rhino, you can also go to the new in version 7 and find this subdivide tool. You can see how cool it is. For example, if I want to make a subdivided box, I can just draw a box here. And let's just go to the shaded mode, and you can see that we will have this subdivided box. Just a quick overview on the subdivided surface. It's a new surface, different from mesh and NURB surfaces. Sub-D surfaces actually have these kind of connections. So it's a kind of advanced NURB surfaces, which they have the curvature completely along the edges. You can see that you have the curvature here, but to make more complicated surfaces, they have added this tree connection. So that is basically how you can use that. And just a quick tip, you can also use the Control Shift and click on a face. If you click on this small circle, you can extrude it a little bit up and make a new subdivided surface. That will open up lots of possibilities you can make in Rhino Grasshopper, and we're going to talk about that in the near future. Okay, let's go to our tutorial and make this simple curves, parametric curves in Grasshopper. So what I want to do here is to go to this curve section and use a simple circle to draw a circle. Let me just put the bifocals plugin here, and let's give this a radius, for example. I'm going to delete the number slider, so it's a radius. That is the circle, the base circle we want to work with. So you can see that I can change the radius here. Okay. The next part is to make a series of connections. For example, I want to divide this circle maybe to 3 different sections and then connect a line to that. So for the Multipipe component, you have to have these curves separated. Okay, you can't make it. For example, if I just bake this circle and also draw 3 different lines here, and then go to this surface sub-D Multipipe component, give this set multiple curves, connect them together, you can see that this is not going to give you a connection. You have to, for example, split it here into 3 different sections and then set this to the input. Okay, let's just set all of those curves, and here you go. You can see that we can make this connection. Again, you have to fix it here. So we're going to make that from scratch in Grasshopper so we don't run into any problems. So let's get back to the circle. What we have to do is to also connect a point to this, set a point. So this is going to when you connect a point to a plane, what happens is that it's going to assume that it's the center point of an XY plane, okay? So this is a trick you can use, always connect a point to a plane. And let's just move that a little bit here and get started, okay? I want to divide this circle into different parts, so I'm going to go to the curve, and in the division you can use this shatter tool. Okay, I'm going to connect this shatter, and remember you have to reparameterize the curve. What's happening when you reparameterizing it is going to be from 0 up to n to the 1. So that's going to make it from 0 to 1. For example, if I give it like, let's just make a panel 0, 0.5, and 1. Remember, you have to right click and put the multi-line data on. You can see that that's going to divide the circle into 0, 0.5, and 1. So it's actually making it into 2 segments, right? That is actually dividing it. So let's just do that with a more parametric way. We can use the range tool. You can find it also in the sets, in the sequence, the range. We have talked about this before. If you don't know about range and series and graph mappers and those things, you can check out this tutorial up here, which is about using graph mapper, series, and range. But for now, the domain is from 0 to 1, which is good, and the steps is the division of the 0 to 1. So for example, if I just say 2 to maybe 8, give it to here, you can see if I divide 0 to 1 to 4 numbers, it's going to give us 4 sections, 0 to 0.25%, to 50%, 75%, and a whole. So I'm going to give that to the parameters, and you can see that it's going to make this segments. Let's just connect a pipe to this, so you can see that these are the parts actually divided. Okay, it's something similar to division. Or using a subcurve, but this is easier to work with. So this is the first part. The next part is to draw a series of lines to that. What I want to do is to go to the curve section and use this point on curve tool. Give it to the segments and put it to 0. That's going to give us the starting point of that curve. And then we're going to also connect this center to these points. So I'm going to go to the curve and use this line tool to make a line from the center to these starting points. That's it. So now you can see that I can make a division of a circle, a parametric circle. That's the first step. Let's just make this into a group so it's easier to understand. Okay, now we have the first part. Let's just go and make a twist on the lines. What we can do here is to go to this transform morph and use this maelstrom component, which is going to make that twist. Let's just give that to the lines. Geometry is going to be from the lines. The plane has to be the center of the circle, so I'm going to just go here and connect the center to the plane. It's going to be an XY plane. And now you can see that it's going to just turn off the lines. You can see that it's going to twist those lines, okay? We can just define an angle, right click and put it onto degrees. For example, 0 to maybe 300 degrees with 2 decimals. And you can see that it's going to twist that. Okay. For the first and second input, which you can see the default is 0.1 and 10, it's the radius of the starting of the maelstrom to the end. Okay, so we have to define it. Here what we can do is to just have a multiplication on this. I'm going to just say multiplied 0.1 as the start. It's going to help us when we increase the radius. And 0.9 at the end. So I'm going to just give that to the first, give this to the second. Remember that you can make that even, change that if you want to have different rotations. We're going to make that near 1 if you want to. Okay, that's how you can rotate the lines. But the problem here is that if I bake this lines, you can see these curves, and also bake the segments here, is that those segments is also located on those curves. So what we have to do is to also extract them. I'm going to just connect that to a curve and use these two. Let's put them all in a curve container with a shift key, and you will have these 12 curves and segments in one curve container, and we're ready to go. We just have all we need to get started. We can also change the number of segments. Okay, let's go to the surface and use this great tool in the sub D menu, Multipipe. Okay, we can give that to the curve and we can play with this here. Okay, the problem here is that if I bake this pipe, is that you can see this is not connecting it to the curved lines. So what's happening is that when you rotate it, let me just turn this off. When you rotate these lines, you can see that the location is also rotating. For example, it started from here and it's moving up here. So you can see it's moving. We have to also rotate these segments a little bit. So I'm going to use that rotate 3D, rotate these segments on the center. So I'm going to give that to the center. The axis is the Z axis. Right click and put it on degrees. And now we can give the same rotation angle to this. That's it. That's what you have to do. And now we can connect them together. Check it out that if they are in one group. Yes. And now we can turn this on. Okay. And you can see that that is going to fix the problem. So remember that you have to also rotate those lines. Let's just make that a little bit smaller and work on that. Okay. We can divide, change the divisions. And now let's get to the main tutorial, which is how we can play with this multi-pipe. I'm going to go to this display and connect a custom preview so you can see actually what's happening. Let's give this a color swatch, maybe a little bit of transparency. It's going to help you understand. You can see this is actually the output of the subdivision. If I bake this, you will have the sub D output. That's really great. You can, for example, use the Control Shift, select these parts, and also the down part, for example. Or you can move that a little bit up and make something different. Okay, so, or you can use the Control Shift and select these parts, scale them, if you want to change the center. What we want to do is to play this parametrically in Grasshopper. The first one is the node size. Let's change that a little bit. That's actually somehow the radius of those pipes. You can see that we can change that. Okay. The size points does not really help us do anything. You can see if I just set a point here, it's not going to help. So I'm just right clicking and clearing the values. so we don't really work on these size points. The inputs we're going to work is on the offset, the strut size, kink angle, and the cube fit. So the strut size, let me just show you without using the end offset, is the radius at the center. Just take a look at this. If I decrease that, that's going to decrease the radius at the center. If I increase that, for example, let's just make that smaller, you can see that that's the center. So usually what we can do is to make that a little bit smaller than this one, so it looks better. Okay, here you go. Let's just make that a little more transparent. Okay, here we go. So that is about node size and strut size. The next part is the end offset. So remember that you can start even with 0. If I give 0 to this, it's going to give you something beautiful. You can see that by giving it a 0, this connection is going to go smoother here. Okay, so why not just give this a number from 0 to 10 with 2 decimals and increase that based on your project. You can see that you can change that and get different results. That's the offset at the starts and the ends. Okay, about the kink angle, you can see that the default is like 0.6. If I give it a 0, usually gives us smooth, better results. So I prefer to use 0, but if you want to give it a number slider, don't increase the decimal. For example, you just use 0 to 2 with 1 decimals maximum. So it's going to make it crash when you change it. And you can see that by increasing that, it's going to change the shape. I prefer 0 because it's smoother. So let's just give that to the kink angle. Okay. For the cube fit, you have to give it a number based on your project. So I'm going to start from 0 to maybe 4 with 2 decimals. 1 decimal is enough. And again, just try to play with these numbers. And you can see it's going to jump on a more curved edges like that here, if you want to. Okay, that's going to help. I'm going to put that to 0 too. Now that we have this pipe, it's time to go to the next part of the tutorial, and that is how to extract these edges. Okay? Okay, to do that, it's really easy. You have to go to this intersection and use this mathematical B-rep plane. We have to give it to this pipe. It's a little bit slow, but anyway, it's going to give you the output. And the plane we are intersecting this is the XY plane by default. You can see it's going to give you the curve. So what we want to do is to connect a surface to these curves. If I connect a surface to the output, it's going to give you the surface inside the sub-D surface, but it's also going to give you the big surface outside. So to get rid of that, what we have to do is to get rid of the biggest curve, because that's obviously the curve outside of this form. I can do that by going to this params menu, connect a number. Technique you can use when you connect a number to a curve, it's going to calculate the length, and then we're going to sort it. So I'm going to use sort the list from small to big. You can see obviously we have to have the biggest as the biggest curve. So I'm going to sort this value and then sort the curves also with this kind of keys. So now we have the smallest curves to the biggest, and right click and reverse it. So we have the biggest at the first. That's the technique you can use. And at the end, you can use that sets sequence call index to delete the first one. So I'm going to just say delete the first index, and we will get rid of that outer curve. Now we just have the inside. We can give a surface to that, and that's it. That's how you can make it. If you want to have the boundary, for example, I just showed you here to make a gradient. What we can do here is to, okay, that's all we wanted to do. That's the first part. And for the gradient, what we can do here is to turn off everything, okay? And go to the surface, use this boundary surfaces tool, give it to all of those intersection curves. It's going to convert that into a surface, and now we want to make that into a gradient. Let's just turn everything off. And remember that this is completely parametric. The last part is to use the gradient. So I'm going to go to this preview, display preview part. I think it's in something else maybe. Okay, dimensions, and use this gradient hatch. Okay, you can't give the surface to the boundaries because it's going to give you an error. So I'm going to use all of those curves to the boundaries. Turn this off. Okay. The axis is really important. You can just right click and set one line to define the axis of the gradient. Turn this off. And now you can see that is the gradient. Let's just delete these boundary surfaces and connect a curve to this curve so you can see them. Maybe we just want to give a black color to that. So let's just go to the display and give it a swatch, blackish look. Turn that off. Okay. And you can play with those colors if you want to. Just click and search for swatch. I usually use that color swatch for everything. So you can play with those colors. And you can also change the axis. Another way to define the axis is to go to params and define 2 points. And then go to the curve and use this polyline tool to convert it into a line and then give it to axis. Turn that off. Okay, now, okay, turn that on, preview off. And now we can play with these points. That's really cool. That's how we can also use that, and also turn on this if you want to give it another color. For example, we can just give this another color to the surface inside it. Maybe black was good. Okay, looking good. You can use that also. And remember that you can bake that hatch. That is really great because you can actually have that in Rhino and use that. Or you can even use the display dimensions pattern hatch. That's also great. For example, if I give it to the curves, turn this off, change the pattern into maybe plus grid. That's really cool. Or for example, triangular grid, a scale to it. It's really useful in your projects. You can change the size and the angle. You can just right click and put it in degrees, maybe 0 to, I don't know, 30 degrees, and rotate that. Okay, and then you can bake this and also bake the curves. And here we have it. That's also great. You can have that hatch in Rhino and use it in your project. So I wanted to just cover these small components in Grasshopper for Rhino 7. We're going to talk about other components in the future and use them in our projects, subdivided views. But for now, I guess that this is going to help you. Just tell me in the comments, was it useful? And was the tutorial good enough? And thanks for watching. See you in the next tutorial. Bye.